Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at exponential decay. This is similar to exponential growth. We use the same model, y equals y sub 0 e to the kt power. The difference is that k is going to be negative, and that's why the graph of that function is decreasing from left to right. We use it to model decay. I'm going to use the same approach I used for growth. I'm going to copy all the variables in the formula, and I'm trying to find the value of k. So first, I need my initial amount, and my initial amount was the number of daily newspapers there were in 1940. That's 1,878. If you're watching this in a few years, a daily newspaper is a series of paper that had news printed on it that was delivered to your house. That's how people used to get their news. The other information we'll use to come up with a value for y and t so that we can find k. Y is the number that there were in 2002, and that's 1,457. For t, it's the amount of time it took to happen, and that was 62 years. The year 2002 minus the starting year of 1940. K, we don't know. So we know three of those four pieces in that model we can solve for k. 1,457 equals 1,878 e to the k times 62 power. We're going to solve this just like the ones that we did before. Isolate the exponential part by dividing over the 1878. Then we'll take the natural logarithm of both sides of the equation to get the variable out of the exponent. Remember again, when we take the natural log of e to some power, that just equals the power. Okay, on the left-hand side, we still have the natural log of 1457 over 1,878, and now that is equal to k times 62. We finish by dividing over the 62, and we want to approximate this to 6 places. And again, if we're talking about decay, decrease, then this value of k should be negative. Let's take a look. Now, let me clear all that out of there. We're going to start with the logarithm of that fraction. So function, logarithm, back to main, 1457 divided by 1878. Let me go back and make sure I had both of those numbers right. 1457, 1878, that's good. And now I want to divide all of that by 62. So I tap outside the parentheses, divided by 62. And there we go. To 6 places, that's negative 0.0040939. That's going to be 094. So negative 0.004094. You can kind of think of that as a percent rate. And so as a percent, that's about negative 0.4%. That shows how it's decreasing from year to year, essentially. Let me keep that number on the screen. I'm going to write y sub 0, k, and t. The value for y sub 0 doesn't change. That's 1,878. The value for k we just found, negative 0.004094. And it says, use the function to determine when there will only be 500 daily newspapers in the US. So we're either going to be given a value of y, newspapers, and find the time, like this problem, or we're going to be given the time and try to find the number of newspapers, y. So in this problem, we're trying to figure out when there's going to be 500. The time is unknown. Let's go. Y equals y naught e to the kt. 500 equals 1878 e to the negative 0.004094 times t. Divide over the 1878. that isolates the exponential part. Now we'll take the natural log of both sides. And we have the natural log of 500 over 1878 equals that exponent, negative 0.00490. Whoops, glad I caught that, 0.94t. So I may have said that correctly, but I sure didn't write it correctly, and that's how we get in trouble. So just be careful there. Finish by dividing by that negative number, negative 0.004094 on both sides. And so we're left with t, and it's time to go to the calculator to approximate this. We're looking for what year this is going to happen. So we should round this to the nearest whole number. I'm going to start with the ln part, and I'll come back in a moment. Oh, I've still got that on the screen. I can use that. Function, natural log, back to main, 500 divided by 1878. Tap outside the parentheses, divided by, now we need that value of k, and that was negative 0.004094. And let's see. So we get 323. And just making sure everything was still good here. So what this is saying, 323 years is a long time into the future. This is just saying that if the decay continues at the same rate, that's when it will happen. So 1940 plus 323 years, that is in the year 2263. Now, we don't know, and it's probably safe to assume that the decay won't occur at the same rate, but this is saying that if it occurred at the same rate, this is when we would be down to 500. All right, that's it for this one. In the next one, we'll take a look at another type of exponential decay.